So in the previous parts of the lecture, we learned about expanded keyword, we learned about once routines, and we learned about export status. So now we are ready to present to you the ultimate solution to the sharing problem that is going to satisfy cohesion and single choice principle. You can argue at the end yourself why the ultimate solution satisfies them. But let me present to you the solution for the Singleton pattern. So I'm going to go to iPad in just a moment, but let me just tell you the three classes we're going to have. So separation of concern, we got one class for data. And notice that we are making use of export status over here for both the constructor and also for the command. Okay, we'll get there in just a moment. Let's start with some very simple class over here just for data. And the data simply just got a value here called V. Okay, and then we got data and also data access. So this is the for the sharing part, and then we are using the once routine. And then this invariant over here, class invariant, is actually very crucial to really understand. I'll get to that point once I get to the iPad. And then we also got a test over here that's more like a client using the Singleton pattern. So we want to illustrate exactly how these things work. Okay. So let me go to iPad here, and let's now try to understand the architecture a little bit more. Okay, so let's say, first of all, you can see this export status over here is applying to the creates. So this means only the data access class, only data access can use the make as a constructor. Only that. So you can see over here, under the context of the data access over here, you can see we are trying to use create result and make, and the result is simply of type data over here. Okay, you can see that's the only class. If you're trying to say outside the context of this particular data access class, for example, let's say in the test over here, if you try, for example, as a first line, if you just try, if you say create, for example, over here, you can simply just try creates data, let's say d1 dot make. If you simply try that, you're going to get compilation error, simply because you can only use the make as a constructor using creates under the context of data access, but now you're doing that inside a class that's outside the data access. For example, it's just a client class, so this will not compile. Okay, so that's the first thing to note. And the second point is about the make is all to really use the make as a command. You can only also use that in the data access class, which means we don't really allow any other class to really call the make outside the data access class. And your follow-up question might be, but what if other client classes really want to modify the integer value v over here? Well, in that case, the answer is we do have one public command over here. You can see there's a feature without any export status restriction. In that case, they can definitely call change v. You will see in the test code how to do it. Well, you want to separate to say make over here is only for the data access class to use. If you really want to have a dedicated command for modifying the attribute, the shared data value, you should create just another one, just for separation of concern. Okay, so that's about the data class. So what about the data access class, which is also important over here? Data access class, you can see data is returning data. Okay, so there's a client supplier between data access and data, right? You can see data access is the clients and data is the supplier. And then notice that this is really important. We're using the once keyword over here. So that means the very first time you're calling the data is going to create a new instance by executing the body of implementation over here. For all the subsequent call, is going to return just the same reference to the same data objects. So that's how we ensure about sharing, right? Okay, so now I want to draw your attention to this very crucial class invariant over here. Data equals data. Let me just make that a little bit bigger over here. So what does that really mean? Okay, you can think about this one here is really like a very relevant consequence of using the once keyword. You can think about the data over here is one call to the data. Okay, the data over here is just a separate call. A separate call to the data. In other words, we have two distinct calls to the same data routine, which is once. So we know that very well. Either, let's say, for example, let's say this is the very first call, this is the second. In that case, they will both return the same reference. That's why equal over here is going to be true, because we're returning the same objects. If this is a second call, this is the third call. Again, all the subsequent call, they will just return the same reference. So equal sign here will still be true. So this invariant here really makes sure that every retrieval of the data using the data query is going to give you the same objects. Okay, so let me write it down here just for the first one. So let me just write down, maybe use different color here. How about orange? So this invariant over here is extremely important. So let me just put it here. Okay. All separate calls to data retrieve the same shared data objects. So this is really important to note. Okay, so that's about the data access class. So now let's move on to the client class. Let's assume that this is a class that is not data and also is not data access. Oh, one more point I forgot to mention. You can notice that there's a keyword over here called expanded, right? We learned about what expanded really means, and we'll see what its use is in helping us define the singleton pattern. Let's now try to trace this code very quickly. Let's say we have a test over here, which is a Boolean test, and we declare access over here of data access type, and also define D1 and D2 of type data. And notice that since data access is actually expanded over here, so remember we said before, you don't have to explicitly initialize expanded objects. In that case, you can directly call access and access right away. So there wouldn't be any void safety issue. There will not be. Okay, let's try this. When you say D1 is assigned to access the data, right? So this is the very first call. Okay, so this is the first call. And then this is the second call. Okay, first versus second. So now when you say access the data for the very first time, okay, let's try that. So when you do that the first time, you're going to execute this particular line over here, which means you're going to create a data object over here, right? So it's going to be data, and then you got V over here. Initial value is simply just 10. Okay, I'll put 10 over here, right? So by executing this particular line, you're actually going to return this particular object, and then I'm going to save that into D1. So that means D1 is pointing to this particular object, right? So now let's try the second one. Let's say I try to call this the second call, the second time. Access the data is going to call this particular routine over here, but because it's once. So now remember, under the hood, we actually got some reference pointing to this particular object. Let's call temp, as we previously defined. But now D2 is just going to point to just the same object over here because it's returning the same reference. So the same reference will be stored in D2. Okay. All the subsequent call will be really easy. It's just only the first call that's going to take some computation for the body of the once routine over here, right? As we said. So now let's try this. When we say over here, D1 equals D2, that should be true because they are really referring to the same object over here, right? D1.v equals 10, yes. D2.v is also equal to 10, yes. So this is also true, okay? And then let's say D1.change v to be 15. So if you follow through the path from D1 over here and change this particular value from 10 into 15, and then it's also going to be visible by D2 because they're pointing to the same objects. So now after this, you'll see D1 is still equal to D2. They are still pointing to the same objects because the same objects being shared. And then you say D1.v is equal to 15. Indeed, it's pointing to 15. D2.v is also equal to 15. That's also true. Okay, so now this is also true. So now what we have done so far, we have presented to you the singleton pattern, which has the data and also data access. We also illustrate to you how the sharing really occurred when we try to write some client code. Finally, the question. Actually, that's something we just illustrated previously. When you say creates D1.make inside the context of this particular test class, in that case, you will not compile, right? As we said before, it simply wouldn't satisfy the restriction for data access over here. Okay. So that's about a simplified example, but it's going to be very similar for any application which you want to use for the singleton pattern. So let me go back to the slides very quickly. Okay, let's say this is an example, and then okay, we already answered that question there. So now what I can give to you as an exercise is as follows quickly. So this is just another instantiation of the singleton pattern. So now we got the bank data. You can see we're trying to do a very similar restriction for the data access over here, right? So now we also just got more attributes over here to be shared in the same objects. And then we also got bank data access. First of all, it is expanded and also is once. And we also got the same invariant over here to say data equals data, right? All the separate calls to the data will return to you the same data object reference. And then we got some account class over here, and this account class will simply declare data access over here because it's expanded, so we don't have to explicitly initialize that. Okay, you can think about the only purpose of defining the bank data access class to be expanded is because we don't want to write extra lines to really say we're going to say creates data access.make. We don't have to, right? Because that's expanded. Okay, and then we can simply call as many times as we like to say data access the data. Only the very first time we're going to execute this line of code. Similar pattern as before, just the same. Similar question because we want to make sure we don't suffer from the same problem as Java solution number 1. So can we actually call data.make as a constructor in other class, in a class rather than bank data access? The answer is no. If you try that in the context over here, you're going to get a compilation error. Okay, the same as before. Okay, this is some code to test about the singleton pattern for the bank data application. I'll leave you to that to really try to trace the code yourself and convince yourself that this test code is really supposed to pass. I'll give you just a little bit of visual guidance over here. If you got any question about going further, please ask me during the Q&A. I'll be happy to answer. Okay, let me just go back here and then let's talk about very quickly about what you should really notice. Okay, when you try to visualize this particular test code over here, what you should notice is you're basically trying to create ACC1 and ACC2, the two account objects. And now the make is the constructor for the account. Let's take a look quickly. Okay, so now you can see under the class account over here, under the make, you're basically trying to say data, which is the attribute over here, is assigned to data access the data. So that means the very first account that we are trying to create, this will triggers the first call to basically data access the data, right? So there will be the first one to trigger this particular data, which is a once routine. Okay, to trigger the first call to data access dot data, which is this particular routine, data and also data. Okay, that's the first one. So that means for that one there, you're going to create the data objects from scratch, just the first time. And then if you try to go a little bit further here, when you say data, when you try to create this particular account the second time, right? So this one here will trigger the second call to data access dot data. So we are calling the same data routine over here, but now since it's for the second time, so you don't really execute this anymore. You simply just return the reference to the same data objects, right? And then you can really try to look at how the aliasing is occurring and also how you compare the reference versus the contents of the data. Okay, so that's something I will leave to you as an exercise over here. I think I already gave you enough guidance about how you can understand the code of using the singleton pattern. The most important thing is to distinguish between first call versus second call. That's the most important point. Okay. Finally, I would like to talk about the architecture for the singleton pattern. Okay, very easy to understand. Okay, the most important part would be, so now if you think about different clients, application 1, you got application 1, you got application 2, application 3. Okay, so now for every one of them, remember we simply declare over here, let's say you can think about account is like application 1. You simply declare under the context of make, let's say data access of type bank data access, and the bank data access over here is of type expanded class. So the arrow you will use is a little bit different. Okay, let me show you here. So now you can think about when you actually use the arrow, you have to use the arrow whose left hand side is actually a diamond to really say it's a singleton, it's an expanded axis. So when you use this, that really means under the context of the application number 1, you have a variable declaration like this to say you got data access, right? So that's a supplier name of type data access over here. And also you're suggesting this particular class is expanded. That's quite an important design decision to show to your reader. So don't forget, this is really important. Okay. And similarly for application 2 and application 3, right? So that's about the first layer of the client supplier. And now the second layer goes like this. For the data access, as we said before, that one there is going to have data. And as I mentioned to you before, typically you do not show any implementation detail in the design diagram. However, this will be the special case that you can allow. In which case, we really want to show the data over here is really a once routine. So that's why I'm putting the once over here, and this is the implementation. I would say if your design diagram really is to show the detail for the singleton pattern implementation, then you may have to include the once into your design diagram. That will be one of the very few exceptional cases. And then this invariant over here would be very, very important. So here you can see, you're going to say data equals data. So this is by reference equality, right? So this is by reference equality. Okay, so that now let's talk about the second layer of client supplier. And because now in the context of data access, you are declaring data of type data. So you can think about data access in this case is the clients. And then we got supplier data of type data, right? Data over here. And then you can see we are trying to say creates data access about using the constructor, and also data access about using as a command. And then also we got the data attribute over here, also maybe some additional command. So this is just a very quick overview about the singleton architecture. So the essence will be you got 2 layers of client supplier. You can think about this is the first layer. So this is the first layer for the client supplier between the clients and also data access. Also, you got a second layer of client supplier over here, which is between the data access and also the data. Okay, and then you have to know how to use the expanded notation and also how to use the once and also the export status. So these are all the ingredients to really make the singleton pattern work. Okay. Please review all the necessary ingredients for the singleton pattern, understand its architecture ultimately, and then make sure everything's comfortable with you. Also, we got some example code made available to you. You can also play with it. Okay, let me make a conclusion for this lecture here by going to the last slide. Oh, there's one exercise here which I would suggest at least you want to think about how to do it. So you may want to think about how to really instantiate this particular shared bank data problem, which already presented in the slides, how to draw its architecture diagram using draw.io. So that will be beneficial. Maybe later on you want to show the singleton pattern in your lab or the project design diagram. That'll be optional exercise for you. Okay, and then beyond this lecture, since you guys all just started with the ETF framework for your lab 3 and also eventually the projects, I would suggest take a look at these classes I mentioned. That's a perfect instantiation of the singleton pattern. Okay, so now I want you to look at a generated class called ETF model. If you don't know what classes I'm talking about, that might be because you haven't really followed through the ETF tutorial video. But if you have, you will know what I'm talking about. Okay, so ETF model class is about a shared data. And also ETF model access, which is expanded, is about how you can give the exclusive once access to the data. And then for all the abstract user commands, so you can see the following, the ETF command. So this is the class that actually declare the model. And also all the effective descendant classes like a move, play, and etc. They will actually try to modify you by aliasing, modify the shared instance. For example, if you look at the ETF command, class itself is deferred, and then simply declare model of type ETF model, right? And then in the constructor in the ETF command, we simply declare MA. Think about ETF command is like a client of the singleton pattern. So we simply declare access just like what we did before, right? And then we will say model is simply assigned to MA.m. You can think about the only class that can actually call the constructor for ETF model is the ETF model access, like what we said before. Okay, and this particular command is the superclass of all the ETF command, for example, ETF move. In that case, you can see that in the actual command action command over here, you can simply just call the model over here, and then upon that, you can simply just try to maybe call some routine that's either going to return something or that's going to modify the model directly. And because we're using a singleton pattern over here, so the model here is referring to the one and only model instance in your system. So that's why the singleton pattern here is really crucial to make the ETF framework work. So that's something I would like you to also keep in mind. Also try to explore these classes a little bit further yourself when you're doing your lab 3 and also your projects.